A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be a part of the module 16, where we will discuss the test done after the construction of the granular courses. Now, at the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, after the construction and the ensurement of the subgrade, thereafter the next layer comes usually your granular sub-base courses or the granular base followed by granular base courses. So, we have already discussed the composition related aspects, the construction related aspects of the granular courses. Today we will discuss, once those are constructed, what are the continuous evaluations which has to be carried out so as to ensure what we expect or what we have thought about we are able to achieve also. So, the quality control exercise which is to be done is a very critical aspect of highway construction, because this is the one, because we do a good design, we do a good proportioning, we have a good construction equipments also, but the entire process has to be monitored very closely and carefully to ensure the product quality. So, quality control is a critical aspect of highway construction, essential for ensuring structure integrity and the long-term durability of our road infrastructure. So, this forms a very important aspect. In recent years, you will see there has been a lot of revisions which have taken place in the codal standards which have been given by MORTH under the flagship of Indian Roads Congress. We will see that the standards or the requirements are more and more getting stringent with year by year revision. So, whatever revisions has taken place, the quality standards have become more stringent, specifically because there has been a tremendous increase in the traffic volume, and then we have an increasing demand that we should have a long durable roads which gives a good riding surface with a very good design speed also. So, in recent years, the need for stringent quality control has grown significantly, driven by rising traffic volumes and the increasing demands of higher levels of service from the highway facilities. So, you can see under this particular discussion, today's talk discussion also will be referring various codal specifications given by Indian Roads Congress. The one is IRC 19, Standard Specification and Code of Practice for Waterborne Macadam. This is again used a waterborne macadam, a granular course used as a sub-base or a base course, which we discussed in previous lectures. Then IRC 109 is there, which is guidelines for wet mix macadam. This is the first revision. Then we have the Orange Book specifications for road and bridge works, MORTH 2013. Then we have the manual for design, construction and maintenance of gravel roads, IRC SP 77. The pocket book for road construction equipments, IRC which is there 2018 publication. Then handbook of quality control for construction of roads and runways. Many other in addition to this will be referred during this discussion. Now, the first aspect whenever layer is getting constructed is to ensure whether it is going as per the horizontal alignment which has been given as per the project requirement. We have the drawings which shows the horizontal alignment of the road. We discuss it when we discussed the subgrade part also. So, here you can see again this is an alignment which has been shown. We can very well see that this is a curve which has been shown. What critical informations or important informations we can draw out of it? We have fixed road level, the finished road level, we have the original ground level, we have the difference between these two, from where we can figure it out. You can see here the original ground level is low compared to your finished road level. So, you need to do some filling here, here also some filling is required, here in this particular again some continuous filling is required, some small portion where some cutting may be required. So, we will get an idea where the horizontal curves are there. You can see this is the horizontal curve with a radius of 250 meter. So, the informations, and we can get the center line of the road, we will get the levels corresponding to the center line, because here you can say this is the levels of the finished road level. So, these are the, if I want to have one at one particular section, if I want to work out, okay, I am doing the construction of this section, so I need to work out. So, this I will be able to see what are my, it has to be projected down, and then I will able to see the with that particular chainage, okay, what is the my finished road level which has to be there. And then with respect to this particular one, using the cross sectional details, this is again a typical cross section where you can see there is a layer of GSB, granular sub-base course, a WMM course, a DBM course, and a bituminous concrete course. There is a carriageway, there is a paved shoulder, some track, cycle track is also there, utility corridors or covered drains are also there. So, we need to have the composition or the crust composition or the typical cross section of the pavement, which gives further detailed information. So, here we can see this cross section gives us information how much is the thickness of your subgrade is there. Subgrade typically constructed for a thickness of 50 centimeter, followed by a granular sub-base course of 200 mm thick, followed by a waterborne macadam 250 mm thick, followed by a DBM 68 mm thick. These are some typical just random values which has been picked up to show this particular cross section. This is for explanation also, not for any design related problem. So, now if I know what is the level at a particular chainage along the alignment, that okay, at this particular chainage this is the finished road level, then considering how much depth is there, this is 108 is there, plus 450 of this one is there. So, you will have 558. So, 558 mm thickness is there. So, whatever levels you have here, you will bring it down. So, that will give you the bottom of your granular sub-base course. So, now if you have constructed, this is a 200 mm thickness thick layer. So, it might have been constructed in one go. If that one layer is constructed, this entire thickness is constructed as one go. Then after the construction of the layer, I will try to ensure what are the levels at the center line, and then I will form grid points, and that grid points will help me to ensure how the cross slope is maintained. So, first I will transfer the finished road level to the level which is at the bottom of my granular sub-base course. Then using whatever here you can see the cross slope is already mentioned as 2.5%. So, I will use workout for this given width, what will be the level at this point. So, my grid points will be accordingly placed, and then I will ensure for the levels at those grid points. So, this will give me that I am following the correct profile, I am giving the correct thickness of the layer. Otherwise, it may happen that I may put up a layer of granular sub-base course which may be of a higher thickness, if it may be say 225 mm. So, in that case, on the top when it is to be reached, it has to get the finished road level. So, in that particular case later on what one may do, since there it has been increased by 25 mm. So, to have the same level on the top finished road level, one may try to compensate with the thickness of WBM, which is not at all accepted. So, this will hamper the performance of your pavement. So, we will not look into it. So, whatever the tolerance is allowed, only that will be accepted. So, this needs to be ensured by doing the exercise for taking the levels at various points. So, this is the first exercise which is required under the quality control part, is to ensure the road alignment, level and surface regularity. So, all construction works performed shall conform to the, because here in this typical example only the granular subbase course was shown as constructed in one layer. There may be two layers of granular subbase course also. So, in that case you will ensure the levels at first layer also and then at the second layer also. Once all these whatever we will discuss today the requirements are checked for a particular layer, then only when the engineer is satisfied with that particular one, the permission is given for the construction of the next layer. So, all construction works performed shall conform to the lines, grades, cross sections and dimensions shown on the drawing. As I show, so the drawings have to be referred, the drawings have to be critically referred to ensure the each layer construction. And you will come to know what are the existing nearby features, as in the previous drawing we were seeing that there are drains also there on the sides. So, utility culverts are also to be there. So, that information will be available from the all your designs drawings and which will be available for your section. So, as directed by the engineer subject to the permitted tolerances described here in after. So, most of the time we go with the tolerances which are prescribed by either MORTH or the a specific code related to that work. So, the horizontal alignment is to be ensured with respect to the center line of the carriageway as shown in the drawings. We have seen that we get the levels for the center line of the carriageway and then we bring it down to layers, and using the camber we can extend it to the edges. Here one important is the edges. The edges, when we reach on the top, the carriageway is the top where actually the traffic moves over it. So, needs to be correct within a tolerance of plus minus 10 mm. So, it is a very small tolerance of plus minus 10 mm. The edges should be either plus, but this is on the top for the carriageway. When you are working with the lower layers, it says the corresponding tolerance for edges of the lower layers of the pavements is plus minus 25. And I will always prefer that you go for some extra, it should be, because that helps you to ensure a better control. Later on you can have a good gentle slope for your side slopes also, if you can have a better compaction at the edges also. So, preferably, because this is not a significant quantity, so you can go for extending specifically to take care that the edges are not getting reduced, because they can be well kept beyond whatever the minimum requirements are there. So, we can have it on the positive side. Why a limit on positive side? Because if you go more than that, definitely it incur more cost, more material is to be put there. The levels of the constructed granular subbase course or the granular course shall not vary from those calculated with reference to the longitudinal and cross profile, which I mentioned that once you have the center line levels, you bring it down to this individual layers, first layer, second layer of granular subbase course, first layer of WMM, first layer of second layer of WMM accordingly, and then using the camber you extend it to the edges. So, you need to check it with reference to the longitudinal and cross profile of the road, and the tolerances are defined which are here. These are the common tolerances which are defined. Specifically for subbase course, it shows that the surface level should be plus minus 10 mm. Now, when it comes for the base courses, it says the base courses we will always prefer nowadays, we with the construction we always prefer, as we discussed that during the construction of wet mix macadam, we will prefer that a wet mix plant is there and we lay the wet mix macadam using a paver. But otherwise, so if it is a machine laid, the tolerance has to be within plus minus 10 mm for base courses also. In special cases where the site does not permits, and if you have to go for some manual laying of these courses, then a tolerance of a slightly higher tolerance is allowed. Now, this for verifying this particular one, we will be using the straight edge. So, to for verifying this particular one, we will be taking the levels through the help of, we can use a dumpy level, we can use a total station, and a leveling exercise has to be carried out. So normally we have a team of surveyor who do this exercise. So and we will verify, we will ensure we can do some cross checks simultaneously wherever we feel. So to verify the compliance with the above requirements for granular subbase based courses, surface level measurements are typically taken on a grid points. This has to be done prior before you start this exercise. So grid points are marked on whatever stretch which is ready with you, and typically spaced at 6.25 meters longitudinally and 3.5 meters transversely. So we mark the grid points by some chalk or chalk powder or lime powder, and then we do this exercise of taking the levels. When you have ensured it and you figured it out, okay, the levels are within these tolerances for sub-base course, granular, if it is within plus minus 10 mm, fine. If you are at some locations, you are finding some points are going beyond these tolerances, either the thickness is more or the thickness is less. In that case, what may be the problem? If I'm doing up, say, a sub-base course with the thickness which is less than what is prescribed. So in the earlier example where I mentioned that, okay, 200 mm of GSB is to be there. Now if instead of this plus minus 10 mm, if because I have done it manually, so I was not able to have a better control over the thickness. So the thickness when it was compacted, it arrived to a thickness of 180 mm only. So it is 20 mm down, it is beyond the accepted limit. Now the problem which arises is because now you have the next layer which is to come over it. So if you have a, say, 200 mm of WMM which is to be constructed over the 200 mm of GSB, which is now constructed as 180 mm. So when you will go for the next layer, the problem is you have this one as, so you have a first layer of 180. Now you want to maintain the levels at the top of your WMM. So then you have to balance out this 20. So this will be 220 mm. So at certain locations you might be constructing a WMM layer of 220 mm thickness. Now when you prepared a trial stretch, considering 200 mm of wet mix macadam only. Now but at field the thickness came out to be at certain locations, because this will not happen throughout the entire stretch. There may be certain portions where because of some challenges or lack of control the thickness got reduced. So there the overall thickness of WMM will become 220 mm. Now this will not get compacted by the same compactive effort which was decided on the basis of a trial stretch of 200 mm thickness. So at this point you will have a layer with a lower density, because the same compactive effort cannot give you uniform density throughout the depth of 220 mm. So it is always important that not only the layer should have a thickness more than that, the tolerance which is given, it should be ensured that it is not more than the positive side of tolerance as well as on the negative side of tolerance, because the compaction may become a challenging concern thereafter. And it says among any set of 10 consecutive measurements which are done for ensuring this level, either taken longitudinally or transversely, usually no more than one measurement is allowed. And that one measurement which is also allowed should not be more than 5 mm. If that is there, then rectification has to be done. So you have to figure it out, the sections where rectification is required. So you have to, once you get the level sheet with you, you worked out, and then you have to figure out the points where the tolerances has gone beyond the stated limits, and then you can visit that particular section, see what is actually happening, what may be the problem, and then you need to rectify that section or localized part of that particular section. Once this is done, once we are able to check these surface levels, thereafter we are going to look for the surface irregularity, or we are going to check for the evenness of the surface. So the longitudinal profile has to be checked, and this surface regularity we check using a straight edge. So this is how it looks like. You can see this is usually it's a standard 3 meter edge which we use for measuring the surface regularity. And finally what the purpose is, at the top, it is not only the levels which are maintained, it is that you get a very smooth or even surface. So that evenness or the smoothness or the surface regularity has to be maintained from your bottom layers, and it should become more and more stricter as you go on the top, so that finally you get a very smooth surface when the wearing course comes or when your carriageway comes. So the longitudinal profile is to be checked with a 3 meter long straight edge, usually a moving straight edge, because it is a long exercise. You keep on moving and you keep on ensuring the surface regularity, preferably, and we do this particular one preferably at the center of a lane which is parallel to the center line. So we do it at a middle of each lane along a line parallel to the center line of the road. So if there may be, say, 4-lane carriageway, this is your center line, and these are 2 lanes on this side, these are 2 lanes. So we will do, this is the center of this lane, this is the center of this lane, this is the center of this lane, and this is what your center line which is there. So we will do this exercise of the measuring the surface regularity using straight edges along the middle of this particular lanes, and we will do it longitudinally also. It can be done transversely also. So the 3 meter straight edge, which is typically made up of a steel or box type aluminum alloy bar with sectional dimensions. These are typical dimensions. There may be a slight variation which is that of 75 mm into 125 mm. Its edges has to be perfectly straight and free from dust and other defects, and then a wedge is used. That wedge is typically, we have a length of around 60 centimeter length is there. The width of that particular, you can see this is the wedge which needs to be inserted below this straight edge. So the wedge is usually having a length of 60 centimeter with a width of 3 centimeter and a height of 3 centimeter on one end, that is around 30 mm, and a height of 1 mm on the other end. So that this you are going to insert under this straight edge, and you are going to, and there are markings which will be there on this particular sides also, on the top also. So then you are going to insert it, and you are going to see where the maximum variation is there. So, and that is said that, so with this particular one, since one end thickness is 1 mm, other end thickness of this wedge is 30 mm, you can usually go up to depressions of say 25 mm. So maximum depressions if lowering points are there. So you are going to insert it, and you are going to check that there should not be a difference of more than 8 mm. So it says the maximum allowable difference between the road surface and the underside of a 3 meter straight edge, which you are going to check by inserting the wedge under it, when placed parallel with or at right angles to the center line. So as I mentioned, it can be done at right angles also to the center line, but preferably it is done parallel to the center line in the middle of the lane, and at referred point shall be 8 mm. So this is the maximum allowable difference, which says that it should be not more than 8 mm for both granular, subbase and base courses. So this is what an important aspect is, that this difference should not be more than 8 mm. So this helps us to ensure that when we reach on the top, we are able to get a very smooth surface. Now, in addition to, as I said, that the requirements are becoming more and more stricter with the various revisions which are happening in the IRC codes. So again, IRC 19, which is there for waterborne macadam, states some more requirements over it. It says, because we have used coarse aggregates in waterborne macadam. If you recall back, we in the construction of waterborne macadam, first a layer of coarse aggregates was laid and compacted, followed by putting up of screenings and water compaction, thereafter followed by putting up the binding material and compaction of it. So here it says the IRC 19, it says that when you are using the aggregates, coarse aggregates of different sizes, 2 sizes are mentioned here. Typically, we go for a thickness of 75 mm for waterborne macadam. In certain cases, the 100 mm thickness is laid. So now what it says that if you are using aggregates, coarse aggregates of this size, then the longitudinal profile measured with a straight 3 meter straight edge, it says maximum permissible surface unevenness. There also it mentions that okay, if you at one place if you are able to find that the surface unevenness is 15 mm, this is allowable for this one, and along with it, it says what maximum number of undulations permitted in any 3 meter length exceeding 12 mm. So, along with this, this is the maximum one. In addition to this one, it puts a requirement that if how many number of this kind of unevenness of 12 mm can be allowed. So, it says that not more than 30 in a 300 meter length is allowed for this particular coarse aggregate sizes. Similarly, when it is there for this one, it is the maximum permissible surface unevenness is 12, sizes of aggregates are lower. So, it becomes more stricter, and there it says for 10 mm, now not for 12, it says that the maximum number of undulations permitted in any 300 meter length, which you are doing the measurements with respect to your straight edge. When you do these measurements, so if you are able to find out that there are certain undulations of 10 mm, then that should not be in a number more than 30 in a 300 meter length. Otherwise, you have to reject that particular section. It needs to be rectified before the construction of the next layer. Similarly, it says if I go transversely with respect to the center line, then for this particular one, what is the maximum undulation, and especially transversely we can use camber plates templates also for measuring the undulations. So, there also for the transverse it says that for this aggregate size, this is the maximum permissible variation for 12 for aggregate sizes of 90 to 45, and for these two aggregate sizes it is 8 mm. These requirements followed on the site will help you to achieve a smoother surface, and that from the very beginning, from your granular, from your subgrade top or subgrade levels to your granular courses, which may be granular sub-base courses and granular base courses. Waterborne macadam, which is used as a preferably used as a base course, in some cases it is also used as some base course. So, the maximum here also it says the maximum allowable difference between the road surface and the underside of a 3 meter straight edge shall be 8 mm for WMM course, which is, so for WMM also it says that it should not be more than 8 mm as per IRC 109/2015. Now, when we have ensured it, we have ensured for the surface regularity, we have ensured for the levels. Now, if we found that certain sections are not meeting the standard requirements, then what to do? So, the rectification, there are certain standard ways of rectification which are already given in our codal guidelines. What this is that where the surface regularity of the sub-base course falls outside the specified tolerance of 8 mm, the same need to be rectified. So, what is to be done? Where it says if it is high, in the case when the sub-base or base course is high, it shall be trimmed and suitably compacted. So, it needs to be trimmed there. So, grader is a one suitable equipment which can use which can be help, or we need to have rippers that will lose the material, and then it has to be trimmed, and again it may be required that you need to sprinkle water and recompact it. Where the density is found to be less, this is specifically when there is a challenge with respect to the levels, where the density is found to be low. Now, this control of density again in upcoming slides we will say, but at a certain location if we find that the density is low, then what we can do, there may be a reason with respect to the any say gradation, there may be some segregation may be there, or excess water may be there. So, we may have to open up that section, we have to aerate it. When we will open it, scarify it, if we found that there is some segregation is there, there is some the material is not meeting the gradation requirement, we have to replace it with the new material, or we have to add precautionally, carefully add the material which is lacking therein, because this is a difficult exercise to do this particular. So, we will scarify the affected layer, add the suitable fresh material. This is important, only that is to be added which is lacking, or otherwise complete has to be removed and a new material has to be put up, and recompacting is to be done as per the required density requirements. The density achieved shall be at least 98% of the maximum dry density. This is for granular sub-base course. The density which has to be achieved is 98% of the maximum dry density, which we got from IS 2720 part 8. Now, when it comes to waterborne macadam, where we discussed that this is a process involving the laying of coarse aggregates, followed by screenings, followed by binding material. There also, if we see that there is certain irregularities are there with respect to the surface level, then it says in that case the entire thickness has to be removed. So, entire thickness, normally as I mentioned, the waterborne macadam is usually constructed with a thickness of 75 mm. So, the entire thickness has to be removed for that particular section. So, the entire thickness of the affected area shall be scarified, reshaped with additional material. Now, you need to work it out what were the reason behind it. It was the aggregate sizes which were, there was some segregation was there, what was the thing, whether the adequate water content was not there, fine screenings were not proper, or binding material is not proper. That care has to be taken up when you are reconstructing it, so that the mistake does not appears again. So, it is important when you are doing it, the rectification, the correct material has to be now used. So, with additional material or removed and replaced with fresh material. So, because it will be difficult now, you will be having coarse aggregates along with the screenings, along with your binding material. So, reconstruction using the same material will be difficult. So, you have to bring up fresh material specifically for this one, and then again the recompaction exercise has to be carried out. Now, for this particular job, you cannot go for very small section because the compaction has to be taken up. So, it says that the area when this kind of rectification is required should be at least 10 square meters of area has to be taken up. So, if any localized spots are formed, you need to scarify it to get at least an area of 10 square meters. So, then you can proceed with this kind of rectification. Under no circumstances, this is usually the big mistake which is normally done in many cases. What we do, if we find small surface depressions, we go on using small screenings or binding materials. So, this changes your complete gradation of the layer, and this will hamper your performance. So, this should not be permitted. So, it should not happen that whatever depressions, because the depressions are small enough, you will not be able to put the coarse aggregate in those depressions. So, you have the screenings and the binding materials, you will put up those screenings and binding materials, and you are going to try to match up the depressions. This should not be at all permitted. This is a wrong practice which needs to be taken care. And once that has been rectified, your surface will be okay in terms of your levels, in terms of your density. And density measurements also, we will discuss density measurements. Compaction ensurement has to be based on not a single measurement. There is a requirement how many number of tests. We have to do one set of tests. In one set of tests, there may be 6 measurements, 6 to 10 measurements, and this measurement, the requirement in one set of tests, whether to have 6 depends upon the material availability, variability in the material which is available. So, this comes when you are there on the project. If you find that there is lot of variability in the material, under one set you can go for 10 number of measurements. So, this you have to make a decision, because usually expected to have a measurement of around 5 to 10 in one set of evaluation of compaction. Similarly, when it is to be done, when any rectification has to be attempted in wet mix macadam, there again it says that the entire thickness, usually WMM preferably constructed with a thickness of around 100 mm. So, there also it says that the entire thickness of the affected area is scarified, reshaped an additional material or removed and replaced with the fresh material. Because normally in case of WMM, if some segregation has happened, even when the paver is doing this laying, because there may be at the end of the day's work, chances are there when your entire material from the hopper of your paver is getting moved out. So there may be chances that some segregation may take place, which has to be controlled. But if it has been it is not controlled, then you will find some segregation is there. Segregation will lead to a reduced density in that case. So, or there may be, as I mentioned, some excess amount of fines has entered because of any other challenge at the wet mix plant. So in that case, either it has to be scarified. If there is lack of fines, if possible, it can be added and mixed up with the help of a grader, then it can be attempted, or otherwise the entire material has to be removed and a fresh material has to be put over it. There also it says that will not have an area less than 10 square meter. So at least a width of 2 meter by a length of around 5 meter has to be picked up if you want to rectify any particular spot in wet mix macadam layer. So it says that the entire depth, if the depth is more than that, then also, because there is a requirement which is mentioned in IRC 109 and MRTH, which says that the top 75, if not the entire depth, the top 75 is to be scarified over the affected area, and then the whatever the deficient material is to be added, or the complete has to be replaced with a fresh material. Here also it says in no case the depressions are to be filled with unmixed and ungraded materials or fines, because you will have certain fines may be available. So it is never permitted, because this will change the complete gradation and the functioning of this particular layer. So we will not permit this one, and this will create concerns later on. So we will not permit any direct putting up of some fines or unmixed material to fill up any depressions which are there in the wet mix macadam. Now there are again during the continuous construction process, there are certain requirements of test which needs to be carried out. Say, and this is given as per MORTH. There is section, a definite section is there, section 900 is there, which states what control test can be done for this particular one. Say for granular materials, granular coarse material, it says gradation, you need to ensure one test, you do a one test per 400 cubic meter of the material. At above limits, to ensure your plasticity index, do one test per 400 cubic meter area. Moisture content prior to compaction, one test per 400. Definitely you have already have moisture content from your laboratory determination of your mix design, during mix design at laboratory scale, then from trial stretch also, but this needs to be continuously monitored at the site at regular intervals. So density of a compacted layer, so it says one test per 1000 square meter of area. So I am doing any stretch which may be say 10 meter wide. So and this may be say around 500 meter of stretch, half a kilometer length I have constructed. One can prepare this much length of a bed in a half day's work. So this is a width of 10 meter and a length. So this will account to me say 5000 square meter of area. Now with this 5000 square meter of area, it says one test per 1000. So it already says that in 5000 you require to have 5 tests. Now there may be a requirement that for judging the quality, and the case may be, it may be only say 300 meter. In that case 300 square 3000 square meter of area will be there. So there will be only 3 test requirement. But it says when you do this compaction related checks, at least in one set you should have at least 5 to 10 measurements. So whether your area requires only 3 tests, but it says because you have to do some statistical measurements to ensure the quality of compaction. So at least for that some minimum measurements are to be done, and that minimum measurements are usually in the range of 6 to 10 measurements under one set. So under one set, if this is there, I will prefer under the 3000 square meter of area also, where only 3 tests are required, but as per statistical requirement I need to at least get 6 to 10 measurements. So, that needs to be done out. So, deleterious constituents you can as per the site constraints and as per the variability observed there in the field, you can carry out at any place. Similarly, CBR it states as per your requirement, wherever you want to check that the material there is no variability in the material, then you can do the test at a longer interval. Otherwise, you can reduce the interval where you are going to do the CBR evaluations also. So, similarly, it is there for waterborne macadam also. Aggregate impact value is to be ensured. Grading of the aggregate, it says 1 test per 250 cubic meter of area. The shape is to be ensured, it says 1 test per 500 cubic meter of aggregate is to be there. Atterberg limits, again it says 50 cubic meter. Now, here it says one need to look into it. It is for screenings and the binding materials. So, the Atterberg, because to determine the plasticity of plasticity index or the plasticity of the fines, so the Atterberg limit measurements have to be done, which says that for your binding material the frequency is more. So, it is 50 cubic meter of your binding material, and for screenings it is 100 cubic meter. So, that this helps to ensure that there is a consistency in the quality of the material which we are using. Similarly, here we have the frequency of quality control test for wet mix macadam. Gradation is there. It is as per IRC 109/2015. It says that you do 1 test per 500 meter cube, subjected to a minimum 2 tests per day. So, either if you are going for a construction of say only in one day you are working out with say 300 meter cube of the material, then also at least you have to do 2 tests. So, minimum 2 tests has to be done. This is to be plasticity index, again it says 1 test per 500 meter cube subjected to a minimum 2 tests per day. Moisture content prior to compaction, this is important, because see, rectification is always a challenging task. It disturbs this layer, it is more time consuming. So, we will prefer that we will have better controls during the construction itself, so that we do not require to do some rectifications at a later stage. It is always better to what we say in other terms, it is precaution is better than cure. But yes, if some default has taken place, then definitely you need to rectify it. So, moisture content prior to compaction has to be ensured, so that you get the with the compactive effect you get the required density. The trial stretch plays a very important role in this manner. So, density of compacted layer, it says 1 test per 2000 meter square subjected to a minimum 4 tests per day. And then as I said, depending upon for your statistical requirements, how many number of tests you are going to do. Aggregate impact value or Los Angeles aberration value, and the shape needs to be ensured. So, these are already requirements. So, there is a continuous exercise which goes. We have a laboratory setup which will be there at the site. We have the laboratories there at our plants. So, the samples will be continuously taken, evaluated in the lab, and the reports are to be continuously shared with the field professionals, so that they can continuously get an information about the uniformity and the construction quality. Now, the compaction control, as I said, we need to, the frequency is already mentioned, and in addition to this particular one, it says that when we are having the granular courses, specifically granular sub-base courses, it says at least one set of 10 density measurements for every 3000 square meters of area. So, it says one set is having 10 density measurements, and this should be at least done in 3000 square meters. So, it gives an idea about how much should be the frequency, and even we can have it at a closer intervals. If we find that the variability is the mix is having or the aggregate is having more variability, we can reduce this particular one, we can have more than that measurements, or instead of 3000 we can make it 2000, and that a set of 10 measurements in 2000 square meters of area has to be done. This is what just a tentative guideline which is given by MORTH. So, tests locations, and another important aspect is that this should be a random sampling techniques. I will discuss this random sampling techniques when we will discuss the bituminous bound courses also. It should not happen that when a stretch is there, one stretch is ready, I will not do all my prefer to do all my test on the edges, or I will prefer to do all my test at the middle of the lane, because the possibility may be there at the edges the compaction may not be that good compared to what the compaction may be there in the middle of the lane. So, if I am only going to take measurements at the middle of the lane, I may get densities which are quite good compared to what may be there on the edges. So, I will do random sampling so as to get a complete picture of this particular one. So, I need to do some random samplings here in this manner. So, this random sampling is very important. It has to be decided, and then the compaction measurements has to be taken up. The locations for random samplings has to be decided, and then these density measurements has to be done. Now, it says that the test locations shall be chosen only through random sampling. If non-destructive tests are carried out, the number of tests shall be doubled. This is another concern, because as we have seen, a sand replacement method is there, which is a destructive test. There, if you are doing that measurement, but instead of it, if you are using some density gauges, whether it is a nuclear density gauge or a non-nuclear density gauge, we have already discussed that nuclear density gauges have higher accuracy, but certain concerns with related to health and environment are there. Non-nuclear density gauges, they are also coming up with higher accuracies nowadays, but compared to nuclear, their accuracy is slightly less. Now, when you are measuring these density checks, or you are doing these density measurements with these non-destructive methods, especially the density gauges, because here you need to do a lot of calibration, and this calibration has to be done regularly. If there is some change in the material variability, we have to do more calibrations. So, that is why it is said, in case of non-destructive test, you may have to require the test which you are doing in case of the destructive test like sand replacement method. So, this is another concern is there. If considerable variations are observed between individually density results, the minimum number of tests in one set can be increased. As I said, it can be 6 to 10. So, if I am finding 6 is not working out, more variability is there, I will go for 10 number of measurements in one set. And the acceptance criteria same, this is why, because one stretch, I'll go with one stretch, say I'll go for 8 density measurements, I'll go for some random sampling, I can go in this particular manner. So, if I am going to do in this particular manner, I'll get my things. So, I'll randomly distribute these compaction checkpoints, and if 1, 2, 3, 4, 5, 6, 7, 8. Now, this 8 points, the density measurements will be done, and then it needs to be ensured what it says, that the mean density of these 8 points shall not be less than the specified density. And what is the specified density? Specifically for granular subbase course, it is 98% of your MDD. So, it should not be, the mean density should not be less than the specified density, plus this is the number of square root of your number of samples, 1.65 minus 1.65 is square root of your samples into your standard deviation of these 8 measurements. For WMM, and during this particular exercise, when you are doing this monitoring there in the field of the density, you need to ensure for the moisture content, because what you will get in the field, you will get the wet density. So, simultaneously, either you can monitor the water content there in the field using these rapid moisture meters, or along with it you can send the sample to the lab. So, they will oven dry it, will get the water content. Once you have the water content, then you work out the dry density, because you have to compare with your dry density. So, again it says for WMM also, random samplings 5 to 10 density measurements are required, and the number of tests in one set of measurements shall be at least 6. So, as I mentioned, from 6 to 10 measurements are usually preferred one. If you find more variability in the results, you go for 10 measurements in one set. So, along with it, it says if considerable variations, that is 15%, this is IRC 109 again states that if you find considerable variations, that is 15% and above are observed between individual density results, the minimum number of tests in one set of measurement is increased to 10. So, either you, because many a times you have to justify it. So, you can say as per my codal requirements, it says that within individual measurements, if the variation is more than 15%, I will go for 10 measurements to ensure whether this particular stretch is okay from the compaction point of view, and the next layer can be allowed. In addition to this particular one, because it says that there can be the acceptance criteria for compacted WMM can also be checked to comply with the following requirements. What the following requirements? If I am going to see, I need to increase my number of tests. So, I am increasing from 6 tests in a test to 7, 8, 9 or more. So, here it says along with it minimum average value, it says that percentage relative compaction is to be this one, 100.5, 100.6, 100.7, 100.8. It says minimum average percentage relative field compaction. So, this also needs to be simultaneously ensured. Minimum value of any single test, minimum value of, and this is the percentage relative field compaction, and then it says a single test, what can be the value for a single test. If you are doing 6 tests in a test, what can be there if you are doing 7 tests in a set, and what can be there in 8 and 9. So, this is, you can see that the minimum value when you are doing in increasing the number of tests is because you are getting more variability. So, this you are 98% may be your desired one. So, if the variability is more, then or this is more than 15% as mentioned in the previous slide, you may need to increase the number of tests in one set. So, these checks are to be ensured. So, we need to check for the levels, we need to check for the surface regularity, we need to check for the material consistency in terms of gradation, in terms of the physical characteristics of aggregate, in terms of the plasticity index. And during construction, we need to monitor for the moisture content, and along with that we will do the compaction control checks. And if things are found okay, we will allow for the construction of the next layer. If not found okay, we will look for what rectification measures can be taken up so as to correct the defect. So, this is all about the field related evaluations for granular courses. Thank you so much.